Linear functions and graphs. The rate of change shows the relationship between two changing quantities. One quantity depends on the other. The following formula is the formula that we use. The rate of change is equal to the change in the y value over the change in the x value. For this first example, we see a table where we have x's and y's and the way they correspond. So to find the rate of change, what we're going to do is pick two of the points. For example, the first one maybe, and the second one. And we're going to take the y's, and the change in means subtraction. So 220 minus 200 over the change in the x's, which would be 12 minus 8. That gives me 220 minus 200 is 20. 12 minus 8 is 4, giving you a rate of change of 5. And the second problem here, we have a graph, and we do a similar thing. We pick 2 points, so it looks like we're at about right here, about 110. And then if we pick another point on the graph, looks like we could actually pick this point right here, which would be the point 0, 8, and then we do the same thing as we did before. So that would be 10 minus 8 over 1 minus 0, 2 over 1, so the rate of change is 2. The rate of change is also called the slope sometimes. The slope is equal to the change in the dependent variable over the change in the independent variable, or a simpler way to say it, the change in y divided by the change in x. Now, mathematically, if you have 2 points, you might use those 2 points and set it up like this, like y1 minus y2 over x1 minus x2, which is the same thing as saying y2 minus y1 over x2 minus x1. It doesn't matter which order as long as the points that are stacked on top of each other are to the same point. So we're going to find the slope of these next points. So pick one point to be your first point. The first one, 0 minus negative 2 divided by negative 1 minus 3. 0 minus negative 2 is a positive 2 over a negative 4. Simplify that, you get a negative 1/2. So the slope is negative 1/2. Next point here, it doesn't matter which one you pick to be first. 3 minus negative 1 over 1 minus 4 gives you a 4. Double negative here makes that positive. 1 minus a 4 is a negative 3. So the slope is negative 4/3. There are certain instances where there are special slopes. Slopes of vertical and horizontal lines are what we could call special. If a slope is 0, then the line will be horizontal. If a slope is undefined, then the line is going to be vertical. So now we're going to find the slope of these two lines. 2 minus 2 over 2 minus negative 3. Okay, 2 minus 2 is 0. 2 minus a negative 3 changes it to a plus. So over 5. 0 over 5 is 0 divided by 5 is just going to be 0. So that slope is 0, which makes this a horizontal line. And this next one, we have the point negative 2, and negative 2, negative 1. So we're going to put our y's on top. Negative 2 minus negative 1 over negative 2 minus negative 2. giving me negative 2 plus 1, which is a negative 1 over negative 2 plus 2, which would make it a 0. Now we can't divide by 0, so this slope is undefined because it's a 0 in the denominator, and that makes this a vertical line. In this next example, we'll have to come up with a couple points to figure out the slope, the rate of change. A student earns a 98 on a test, answering one question incorrectly. So one question wrong gets a 98 on the test. And earns, there's a 90 if 5 questions are wrong. So we also have the point 590. So we want to find the rate of change, basically, how much is each question worth. So to do that, we're going to find the slope between the two. 98 minus 90 over 1 minus 5. Okay, and then you do that, it would be 8 over a negative 4, which is negative 2. So for every incorrect answer, you lose 2 points. So there's a minus 2 for each incorrect answer. In this next example, a car is 200 kilometers from its destination at 1 hour and 80 kilometers from its destination at 3 hours. So if we set this one up, we would have 200 at 1 hour, 200 kilometers away. At 3 hours, only 80 kilometers away. So basically, what is the rate of change in this travel? So 200 minus 80 over 1 minus 3, which would give me a 120 over negative 2, which is negative 60. So now we need to actually interpret this. What does it mean? Well, this means that the rate of travel is 60 kilometers per hour. The linear parent function is y equals x, or in functional notation, f of x equals x, which f of x is really just another way to say y. Slope-intercept form is a common form of writing these linear functions, and that is y equals mx plus b, where the slope is m and the y-intercept is b. In this next example, what we're going to do is identify the slope and y-intercept of the graph, and then we're going to graph it. So first, y equals mx plus b. So my slope is m is 5, and my y-intercept is the b, which would be the negative 2. So that means I'm going to cross at negative 2, and then I'm going to go up 5 and over 1, and then draw my line. So that is the line for example A. And for example B, first thing we have to do is solve for y. So I'm going to distribute here and get 30 minus 18x equals negative 2y. And solving for y, I'm going to divide by negative 2. So I get a negative 15 and a positive 9x. So if I were to simplify that, it would be y equals 9x minus 15. So I'm going to cross at negative 15. So if I'm going by 5s, 5, 10, 15, it would be there. And then I'm going to go up 9 and over 1, 5, 10. So it would be like up and then over 1. So it would be a really steep line like that, something like that. This next example, we are given the slope and y-intercept, and we have to write the equation and then graph it. So my slope is negative 4/5, so that goes in place of the m. And then my y-intercept is 7, so plus 7. So that would be my equation. And when graphing it, crossing at 7. And I'm going to go down because of the negative 4 and over 5. And connect those 2 points, and that would be my line. For the next example, we have 2y minus 6 equals 3x. So to write it in slope-intercept form, I'm going to start by adding the 6 over. And I have 2y equals 3x plus 6. Then I divide by the 2. So y equals 3 over 2x plus 6 divided by 2, which is 3. And then graphing that, I'm going to cross at 3. Cross the y-axis at 3, and then I'm going to go up 3 and over 2. So that would be the line. Another way that we can write lines is in what we call point-slope form. This is easy to do if we're given a point and the slope of the line. We can find the linear equation in point-slope form as y minus y1 equals m, your slope, times x minus x1, when x1, y1 is your point and the slope is m. These examples, we're going to, given the point and the slope, we're going to write it in slope-intercept form, but we're going to start in point-slope form. So y minus y1 equals my m, which is negative 5, x minus my x1, which is negative 3. And then simplify, y minus 6 equals negative 5x, double negative, that makes that positive, so negative 5 times a positive 3 is negative 15. And then add the 6 over, and y equals negative 5x, negative 15 plus a positive 6 would be minus 9. So that is your slope-intercept form when we started in point-slope form. And the next example, we have the point 8, negative 4, and the slope of 2/3. So that would be y minus a negative 4 equals 2/3 x minus 8. So I distribute here, and we have y plus 4 equals 2/3 x minus 2 times 8 is 16 over 3. And that's, multiplying by a fraction. So I subtract the 4 over to get the y by itself. And I have y equals 2/3 x. Now I have to deal with a fraction minus a number. So I need to get a common denominator. So when I do that, I'm going to have negative 16 over 3. And I'm going to change this to make it over 3. And in order to do that, I need to multiply both the numerator and denominators by 3. So right now it's 4 over 1. So minus 4 times 3 is 12 over 3. Okay, and then I'm going to finish it out. Y equals 2/3 x. Negative 16 minus 12 is a negative 28 over 3. That's after you found your common denominator of 3. That's your final answer. In these examples here, all we're doing is graphing it. So right now we're in point slope form. So if I just pull out the point, so my point would be 2, 1, and my slope would be 2/3. So if I just graph my point of 2, 1, and then from that point I go up 2 over 3. So that would be my line of the first one. And then part B, find my slope. It would be 4, negative 7, because our point slope form says it has to be y minus y1. And since it's a plus, it needs to be a double negative there, so it makes it a negative 7. And my slope is a negative 4/5. So if I graph this point, 4, negative 7, it's going to be down here. And I'm going to go down 4 and over 5, or backwards 5 and up 4. Either way, your line has to be going down. Doesn't matter how you do it, but the line has to go down, negative in the end. These next examples are in what we would call standard form, because the x and y are on the same side, and all we have to do is graph the equation. So I think the easiest ways to do that is graph the intercepts. So graph where it crosses the x-axis, graph where it crosses the y, and then just connect the 2 points. So to find my x-intercept, what you're going to do is put 0 in for the y. So that would be 3x plus 4 times 0 equals 24. So that part's 0. Divide by the 3, and x equals 8. So that means we cross the graph at 8, 0, when y is 0. 1, 2, 3, 4, 5, 6, 7, 8. So we're crossing there at that point, and then we find the other point we cross at, the y-intercept, by putting 0 in for the x. And then solve for y. So that's 0 right there. Divide by the 4, and y equals 6. So we're crossing right there. So those 2 points are on the line, so we just connect those 2 points. And that's our line. Next example, finding the x and y intercepts again. My x-intercept, I'm going to put 0 in for y. 3x minus 4 times 0 equals 12. So that's 0 right there. Divide by the 3, and x equals 4. So that point is on the graph. And the next point, the y-intercept, we're going to put 0 in for the x. So 3 times 0 is 0. Divide by the negative 4, and y equals negative 3. That's on the graph too. That point right there. And then this would be our line. Next example, we have the equation x equals 5. In this case, there is no y. So all we know about this graph is that on every single point, x has to be 5. Well, find somewhere where x is 5. So that would be at that point right there. And then think, where else is x also equal to 5? It would be all of these points right here on this vertical line. And the next one, y equals -2. We have no x on this one, so anywhere y is -2 would be on the graph. So it would be this horizontal line right here. For these last couple examples, we just have to write it in standard form, meaning a number times x plus or minus a number times y equals a number. That's our standard form. So we need to x and y on the same side, so I'm going to start by adding the 3 over 7x. So I have 3 over 7x plus y equals 5. Okay, now the other thing that is true about standard form is we can't have fractions. So in order to get rid of the fractions, what we need to do is multiply everything by any denominator. So since we have a denominator of 7, we need to multiply this by 7, this side by 7, and if you do it to one side, you gotta do it to the other side. So that gives me the equation, distributing in the 7 over here, is going to be 7 times 3 over 7 x plus 7y equals 5 times 7, which is 35. Now, obviously, we simplify that, and the 7's cancel out there, leaving me with a 3x plus 7y equals 35. And that would be your standard form equation. And the last one's a word problem. A media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write an equation that describes the items you can purchase. Then explain the intercepts. Okay, well, we know that it's $1 for every song plus $12 for every movie. And you can only possibly spend $60 because that's all you have. So there's your standard form equation. Now, to explain what it means. In this case, the S-intercept would be if you only bought songs if you got 0 movies. So 0 movies gives you the number of songs. Which you would find that to be 60 songs. Okay, and the next intercept, if M-intercept, movie intercept, would be if you got 0 songs, how many movies could you get? And if you solved that, you would be able to get 5 movies for $60. Okay, so that would be the explanation of the intercepts. That's it for the notes on linear functions and graphs. You should be able to summarize your notes and make sure you bring any of your questions to class, and we can work on the worksheet and get ready for the quiz.